who leads the unit, Phil Flanagan and Jenny O'Neill. Today's session will focus on Section 3D of the consultation document, mitigating overheating risks in dwellings. We are recording this session, and this or the slides may be placed on our website for those who want to view it later. This is the 5th session in our series of 7, taking place more or less weekly until mid-October. Any questions or queries on today's presentation, you can send them through to us using the Q&A function. The consultation is live and runs until the 15th of November. Documents are available on our website at the link provided there, or the link shown there. Please respond on Citizen Space. There are quite a lot of questions within the consultation, but they come in different sections and you can pick and choose what you might want to answer. Again, any queries you can email us on the info.bru@financeni.gov.uk email address. So today, Section 3D, mitigating overheating risks in dwellings. This is just a brief overview of what we're going to go through today. Firstly, a background on overheating risks, an outline of regulatory changes in GB. We'll look at how overheating is defined, the application of new overheating standards in other regions, compliance with overheating standards in other regions. We'll go through the simplified methodologies as applied in England, Wales and Scotland. We will look at the alternative method, which is dynamic thermal modelling. We will discuss the usability criteria in relation to mitigation measures. We will overview our own proposed overheating mitigation standards here. We will discuss the typical issues or outcomes to consider. We will, towards the end, we will provide an overview of the consultation questions. And finally, we will hopefully have time to address any questions that you may have as part of this presentation. So to begin and provide some background on the mitigation of overheating, this section considers the introduction of overheating mitigation standards to the building regulations and associated technical booklet guidance as part of the next phase 3 uplift. The background to this is the report provided by the EAC back in 2018 when they held an inquiry into heat waves and their impact on the UK. The outcome was that their final report recommended that government should create a new regulation to stop buildings being built which are prone to overheating. In response to that, England have pushed on. They have conducted some modelling, some further research that indicated that overheating risks in new dwellings in England were quite high, and they have last year, as part of their FLOSS uplift, introduced a new Part O overheating regulation and supporting guidance there, approved document O, and the regulation and the guidance came into effect in June last year. Again, Wales have pushed on, and as part of their uplift late last year, they introduced a new overheating standard, Part O, in November 2022. And again, Scotland introduced a new standard towards the end of last year. All regions, the new requirements are targeted at domestic and residential buildings. So in terms of regulatory changes in GB, the new regulation in England is typical of the requirements in all regions, and it requires the following. Firstly, reasonable provision must be made in respect of a dwelling, institution or other building containing one or more rooms for residential purposes other than a room in a hotel. So the first part, 1A, is to limit unwanted solar gains in summer, and secondly, to provide adequate means to remove heat from the indoor environment. In meeting paragraph 1, account must be taken of the safety of any occupant and the reasonable enjoyment of the residents. And of course, mechanical cooling may only be used where insufficient heat is capable of being removed from the indoor environment without it. Insufficient heat is capable of being, so yeah, we want to encourage passive means as much as possible there. So how is overheating defined? Overheating can be defined as a prolonged high temperatures that affect health and well-being. SIBSE have developed the TM59 methodology. It's the very latest methodology provided for the assessment of overheating risks in homes. The TM59 methodology sets out 2 compliance criteria which both need to be met to prevent overheating in naturally ventilated homes. Criterion A applies to living rooms, kitchens and bedrooms. It requires that the internal temperature does not exceed a defined comfort temperature by 1 degree or more for more than 3% of occupied hours over the summer period. Criterion B applies to bedrooms only and requires that the internal temperature between 10 p.m. and 7 a.m. shall not exceed 26 degrees for more than 1% of annual hours. Homes only need to overheat for part of the time for these criteria to not be met. To exceed criterion B, a bedroom would typically only need to exceed 26 degrees overnight for 33 hours per year, which could occur during a week-long heat wave. The extent of any mitigation measures depends on how much of the criteria have been exceeded, taking into account the scale of elevated temperatures, the duration and the time of day that they occur. The dwelling is deemed acceptable if both criteria are met. If one or both are not met, mitigation measures are deemed necessary. Application of overheating standards in other regions. Firstly, in England, the new overheating guidance applies to residential buildings only. This includes dwellings and other types of residential accommodation, such as care homes and student accommodation. Wales replicate the position in England. Scotland's new requirements apply to residential units and shared multi-occupancy buildings. In the case of conversions, they also apply the new overheating standard as far as is reasonably practicable, and in no case be worse than before the conversion. The Republic of Ireland overheating guidance is included in their Part L, Conservation of Fuel and Power, their TGD. This is similar to the current position in NI. They use their DAP software, which will flag up dwellings that present an overheating risk. There have been no announcements indicating that ROI intends to introduce standalone overheating guidance outside of DAP. DAP will be their equivalent to the SAP software that we use here. Additionally, England have identified high-risk areas and consequently created 2 separate risk categories identified by location. Moderate risk locations, that's most of England, excluding high-risk parts of London. There's an increased risk in London, so they've created this separate high-risk category. So again, that's some urban areas and some suburban areas and parts of London, and I believe also some postcodes within central Manchester are also within the high-risk area or high-risk category. The department does not consider this high-risk category relevant here, given our local climatic conditions. Moving on to compliance with overheating standards in other regions. England, Wales and Scotland all offer 2 separate options for assessing and mitigating overheating risks as follows. Firstly, they all offer a simplified method, and alternatively, there is an option to use dynamic thermal modelling. The simplified method there are different methods, different methodologies already implemented in England, Wales and Scotland aim to limit unwanted solar gains in summer and provide appropriate means of removing excess heat from the indoor environment. The simplified methodology implemented in each region is different, but they do set standards for the following: limiting unwanted solar gains and removing excess heat, and assessment is required. We'll move on to look at the simplified method in England. Firstly, step 1 in England, the designers must categorise the building. So overheating risk, is it moderate or high? That will depend on the location. Is the building cross-ventilated or not? Step 2 is to limit solar gains. So the maximum area of glazing should not exceed ADO table 1.1. So you'll see table 1.1. Designers would decide here, or they would categorise their buildings. They would see whether table 1.1 for cross-ventilated buildings is applicable. If not, they would look at table 1.2 for buildings without cross-ventilation. You'll see on table 1.1 you have standards set there for high risk locations and also for moderate risk locations. On review of this table, I mean, the first questions that we asked were, how do you define the largest glazed facade? Is that the largest facade with a window? Is it the facade with the largest amount of glazing? Is it the facade with the largest amount of glass to wall ratio? So those are the sorts of queries that we had initially thought about. In England, orientation is a factor. So again, that largest glazed facade, is that orientated north, east, south or west? And then that would feed into the maximum area of glazing that is allowed. As you'll see on the column on the right hand side for moderate risk locations, 18% glazing to floor area for north, east, south. It reduces to 15 and west down to 11. So there's quite a bit in there for designers to review and to assess. There is also an assessment of the maximum area of glazing in the most glazed room. So that those are something that are specific to the simplified approach in England, is the assessment of orientation and also the glazing in the maximum area of glazing in the most glazed room. So that's step 2 there, is to limit the solar gains. Step 3 would be assessment of minimum free areas. This is to ensure that excess heat can be removed. So in high risk locations and moderate risk locations, you will see that total minimum free areas are slightly different there. Obviously, moderate area, you will be you won't have to remove quite as much heat. Again, with the step 3 here in England, you have to assess the minimum free area provided in bedrooms as well. So that's another factor that must be considered. Again, table 1.3 is for cross ventilated buildings. Table 1.4 for buildings without cross ventilation. You may ask what free area, what does that mean? So that's the geometric open area of a ventilation opening. This assumes a clear, sharp-edged orifice that would have a coefficient of discharge of 0.62. So you can see where the simplified approach, it is actually in practice, it can be quite complicated. The free area is actually better assessed as an equivalent area and is calculated using the calculation tool provided by Building Bulletin 101. So you'll see with the diagram at the bottom there that the height and width of that window opening, that would be the free area, but of course that's restricted by the opening section of the window itself. So the calculation tool here will or can be used and should be used to provide or to calculate the equivalent area for use as part of the assessment procedure. And when doing this, obviously it takes quite the development of quite a complex schedule. A window schedule would be more complex than maybe architects or designers would use previously. For example, the glazed area is not the typical structural opening of a window. It's only the glazing itself. It does not include the frame. So typically there would be a frame factor applied to that structural opening itself, say of 0.7. So those things have to be considered. And again, G values and so on come into the equation as well. So there's quite a lot in it for architects and designers when they are trying to produce the building control information that's required as part of the simplified method here, using the English approach. Of course, part of the simplified solution, we would also have to consider usability criteria. So noise at night, pollution, security, protection from falls and protection from entrapment must also be considered. Windows would be typically open for a longer period. They may open larger opening sections, and they may open wider than typically we'd be used to with restrictors and so on. So, and we have to consider the impact on that for safety, for noise at night, and maybe any pollution concerns there. Usability issues may mean the standards of the simplified method cannot be met. For example, external noise is unlikely that windows will be opened by an occupant at night time, so therefore the free areas as calculated cannot be delivered. In such cases, dynamic modelling should be used as an alternative. In Wales have a slightly well, I would say it's slightly more user-friendly approach to going through the simplified method there. Firstly, table 1.1, designers would categorize their building. Is it a flat, a dwelling house with cross ventilation, a dwelling without cross ventilation? Wales have undertaken some research, and they consider that cross ventilated dwellings adequately mitigate the risk of overheating, provided the minimum purge ventilation requirements of approved document F are achieved. So for cross-ventilated houses, provided that they as long as any of the mitigation considerations are not viable, so that you don't have any noise problems, there's no pollution, safety or security concerns there, it would be okay just to proceed without undertaking a full assessment. Flats, they do see a risk there. In terms of overheating, single aspect flats or top floor flats would be probably the dwelling types most at risk here. So in Wales, there would be it would be necessary to go through a full simplified assessment as per paragraph 1.2 and paragraph 1.3. So firstly, check the table 1.2 for guidance on approach to compliance. And you will see for dual aspect residential buildings, you have really D1, D2 and D3, so 3 separate approaches with glazed areas, that maximum glazed areas, you'll see 15% for D1. If you go with improved glass with a lower G value of 0.4, you can increase the glazed area to 35%. Approach D3, you have the option to include shutters, overhangs and so on, and again you can increase the glazed area to 35%. In terms of heat removal for dual aspect residential dwellings, the minimum free area remains at 12% for each of those approaches. Again, for S1 and S2 single aspect residential dwellings, you will see that S1 is 15% available for maximum glazed area to floor area for the S1 approach, and if you choose to improve your glazing, reduce the G value to 0.4, you can increase the glazed area to 20%. Again, necessary to calculate the area of glazing. Wales do not consider orientation, so that makes it simpler for designers when they're going through this approach. And there is no consideration of glazing in the most glazed room. Step 4 is the heat removal calculation. So again, total minimum free area as a percentage of floor area must be calculated. Again, in Wales, similar considerations to England, the usability of mitigation measures, noise at night, pollution, security, protection from falls, and protection from entrapment. Again, any issues or concerns there, it may mean that dynamic thermal modelling should be used to achieve compliance. In Scotland, the simplified method, arguably the most simple of simplified methods. Step 1, limiting solar gain through glazing, assessment required. So Scotland assess what they call an apartment, which is the equivalent here of a habitable room. So it's not so much a whole dwelling assessment. Each habitable room is assessed individually. Each room that's orientated along the solar path, so east, south, or west, all those rooms must be assessed there, and glazing at a maximum or no greater than 20% of floor area of the habitable room. If you want to have more glass than that, you would need to provide shading such as louvers, external shutters, or to revise the G value to reduce the solar gain in proportion to the increase in glazing area as above. So that's the approach in Scotland. It will be on a room by room basis for rooms that are orientated to the solar path. So it is a more straightforward approach. Bedrooms and most glazed rooms are not, well, all rooms are assessed, so that's irrelevant. Step 2 would be ventilation to assist with cooling. Assessment should be undertaken on all dwellings based upon the number of exposed facades and arrangement of openings which provide ventilation to apartments or other habitable spaces as follows. So again, cross ventilation and buildings without cross ventilation, that has a big impact on the ability to remove heat. So where a building is cross ventilated, so that's two elevations which are parallel with ventilation openings distributed so that neither has less than 1/3 of the combined opening area, no further action is required. So Scotland lean more on their purge ventilation requirements elsewhere in their technical handbook, the standards. So there's no specific requirement here to provide additional assessment for overheating. So they're content that the purge ventilation requirements required elsewhere is enough to remove any excess heat and to mitigate overheating. So that's a big help there for designers. In single aspect rooms there, without the ability to cross ventilate, it would be necessary to increase the purge ventilation by 50%. That's just to provide some additional ability there to remove excess heat. So that's the approach in Scotland. Probably the most user-friendly approach for designers, and in terms of developing building control documentation. Again, in Scotland, similar to Wales and England, we have the usability of mitigation measures. So noise at night, pollution, security, protection from falls, and protection from entrapment. They must all be considered. Things like noise, pollution, if they're raised at planning stage, it will be up to designers to mitigate around those issues and deal with those problems. Any usability issues, again, the alternative means to compliance would be to thermally model a solution there. To expand upon the alternative method, which is dynamic thermal modeling to CIBSE's TM59 methodology, this is a more complex assessment route, and it leads to a more accurate assessment of risk than the simplified method, which sets thresholds for compliance in order to prevent overheating in the majority of cases, and those thresholds are quite conservative. It has been shown that some house types can achieve compliance via this method despite being non-compliant if assessed using the simplified method. Again, that's to do with the conservative approach when using the simplified method. It is possible to achieve a more refined solution using dynamic thermal modeling. So yeah, you have more options there to specify solar shading and shutters and so on. So it's more complex. I believe it also takes account of the thermal mass and the construction of the building. So yeah, it's a more complex approach, and designers can tweak that to find a solution that best suits their needs. There are circumstances when TM59 model must be used. For example, as we said, on a site where concerns with usability criteria have been identified, such as noise or pollution, security also. This method may also provide a route to compliance for homes that have already passed the planning stage and where it would be difficult to make material changes to the proposals as approved. So if you've already achieved planning and you're going into building control after any new overheating regulation has been introduced, you may choose to use this method to achieve compliance with the new standard. It will avoid you going back through the planning process there and maybe reducing glazing size or introducing solar shading and so on. Usability of mitigation measures. So we'll look in a bit more depth here at those usability factors. England, Scotland, and Wales have all implemented similar mitigation measure or similar usability criteria. So All mitigation measures require mitigation strategies to take account of the following factors. Firstly, noise at night. Secondly, pollution, security, protection from falling, and protection from entrapment. We'll take a look or a run through firstly noise at night. So noise at night can present a problem if overheating strategies rely on the opening of bedroom windows during sleeping hours from 11 p.m. to 7 a.m. If noise is identified at planning stage, overheating strategies should take account of the likelihood that windows will be closed during sleeping hours. England indicates specific noise levels in their guidance, which it is likely that windows will be closed at night. Wales require designers to consider noise generated by mechanical ventilation measures, if applicable. This is an extract from AM approved document O in England, and you will see that windows are likely, this is part of their guidance, windows are likely to be closed during sleeping hours if noise within bedrooms exceeds the following limits. So 40 decibels averaged over 8 hours during the period of 11 p.m. to 7 a.m. or over 55 decibels more than 10 times a night during the same period. So England have been quite specific there on their noise requirements. England or Scotland haven't included any sort of decibel limits like that within their own regulation or guidance. Moving on to pollution. England's Part O refers to their Part F ventilation guidance in order to minimise the intake of external air pollutants. Designers should already be familiar with Part F requirements, and Part O does not add any further requirements beyond this. Wales again have replicated this approach. Scotland treats potential pollution concerns in the same way as noise, in that if it is highlighted at planning stage as a material consideration, any proposed overheating mitigation measures should also be cognizant of the problem. Again, so things like pollution and noise, if raised at planning stage, really should be addressed at building control application stage. Security. Further concern, England require that the free opening area available for ventilation during sleeping hours should only be the amount that can be securely provided, and they highlight ground floor and easily accessible bedrooms as being particularly vulnerable to the intrusion by burglars. So the security is a big risk there with openable windows and any accessible room really. England's guidance notes that openings can be made secure by using fixed or lockable louvered shutters or fixed lockable grills or railings. Easily accessible is also a defined term. This is an extract from Appendix A and approved document O, England. So easily accessible is a window or doorway, any part of which is within 2 meters vertically of an accessible level surface, such as ground or basement level or an access boundary. A window within 2 meters vertically of a flat or sloping roof. Again, that's considered to be easily accessible. Wales Part O guidance replicates the position in England with some additional emphasis that security measures should not obstruct the means of escape strategy for fire. In Scotland, where issues such as security, including easily accessible windows, are a concern, and it is not considered practical to simply open windows to assist in cooling, further assessment of overheating risk or alternative solutions may need to be considered. Again, that's offering the dynamic thermal modelling route to compliance as an alternative. Protection from falls. England require consideration of window handle reach distances and 1100mm guarding, additional to the normal or previous requirements for permitted guarding or sill height at windows to be provided at 800mm. Wales again replicate the approach in England, but also add that if exceeding the minimum guarding height, this should not impact on the means of escape in the event of fire. Scotland simply state that any mitigation should not require occupants to circumvent measures intended to deliver a safe environment in respect of issues such as risk of fall from height through openings of dwelling security. Unlike England and Wales, no specific or additional requirements for guarding are explicitly specified. So Scotland have retained minimum sill height at 800mm. Protection from entrapment. England's guidance requires that louvered shutters, railings and grills should not allow body parts to become chopped, with more detailed requirements provided. So this again is an extract from approved document O in England. Similar maybe to balustrades, the current balustrade requirements here. So louvered shutters, railings or ventilation grills should not allow the passage of a 100mm diameter spare. Any hole which allows the passage of an 8mm diameter rod should also allow the passage of a 25mm diameter rod. Such holes should not taper in a way that allows finger entrapment. In addition, any looped cords must be fitted with child safety devices. Wales, again, replicate this position, and Scotland's previous position in relation to delivering a safe environment will presumably extend to protection from entrapment. So, proposed overheating mitigation standards here. Given the removal of Appendix P, that's the assessment of overheating that we currently have in SAP 2009. That's removed in SAP 2010. And given the EAC report, the department is minded to introduce a new regulation on overheating supported by technical booklet guidance. The department expects to work on the basis that only a low to moderate risk of overheating assumption would be applicable across the region, given evidence from the Irish government's research. We don't believe there are any high risk areas within Northern Ireland. And the department currently considers that Scotland's approach is the most practicable, and that a similar approach will be proportionate given presumed similarities in climate data. The simplified approach would require assessment of each room facing west, south or east, such that glazing is limited to 20% of total floor area of the room, or an equivalent reduction supported by a shading or a lower G value for the glass. And secondly, in dwellings or relevant residential spaces where cross ventilation is not possible, or where rooms are not facing north, openings for purge ventilation are increased by 50% beyond that which would be required for rapid or purge ventilation for Part K requirements. Usability criteria would also apply, as we've discussed previously. Again, where this is not possible, or the designer may choose to look more in depth at their mitigation strategy, the TM59 modelled approach could be used to demonstrate compliance. The principal benefits of following an approach closely aligned with Scotland include assurance that all rooms orientated towards the sun path will be individually assessed. Linking heat removal requirements to the current purge ventilation standards helps to reduce the compliance burden on designers. Assessment on a habitable room basis should also enable the requirement checks to apply to extensions and other alterations. The current Part K ventilation guidance already requires a minimum of 4 air changes per hour of rapid purge ventilation to habitable rooms and dwellings, and is the equivalent of England, Scotland and Wales. So again, that would hopefully provide a user-friendly solution here to mitigating overheating. The department is minded that it should apply to change of use applications related to dwellings or relevant residential buildings. The department expects that all reasonably practicable passive measures should be required to be used before including any active measures to mitigate overheating. So passive measures as opposed to going with air conditioning or any other measures that would increase the energy load for that dwelling. Compliance with new regulations would be demonstrated by following technical guidance either in a new technical booklet O, or it could be incorporated within our existing or what will be developed TBF1 or TBK1 guidance. Final regulations and more developed guidance would be subject to further policy development, including public consultation. So there would be a further consultation with as part of phase 3 before any introduction here of an overheating regulation and guidance. Typical issues to consider. The Future Homes Hub provides additional information on achieving compliance to England's Part O standard. They have quite a few documents on their website there. The link is provided. So they go through the simplified approach in England. They also look at the dynamic thermally modelled approach. They look at the impact on building design. Certainly a fairly significant impact there for parts of London there in the higher risk areas. Glazing significantly reduced, sill heights are raised. It has quite an impact on the building aesthetic in London. So worth checking out and having a review of their documents. Fewer challenges and impacts are expected here, given the proposed simplified approach is more straightforward, and because the Belfast weather file used for dynamic modelling is likely to lead to less onerous solutions. Proposed requirements are likely to reduce the extent of glazing in some buildings. This and/or the provision of shading devices may impact planning permissions, as discussed previously. Mechanical cooling may be required in some circumstances if passive measures are inadequate to purge heat. The proposed guidance would seek to minimise this, requiring that all reasonably practicable passive measures have been employed to reduce cooling needs. The impact of mechanical cooling on Part F compliance. Will this be viable? The notional building spec within SAP does not include any allowance there for mechanical cooling. So if you introduce that, you would have to make some improvements elsewhere, possibly to the building fabric or the efficiency of heating systems. So that must be a consideration for designers if they're choosing to, or it's a necessity to introduce mechanical cooling. Other issues: increased openable areas to remove heat present challenges in determining when noise, pollution, security and safety issues should prevent standard openable windows or purge ventilation solutions from being used. Again, noise at night, pollution, security, protection from falls and entrapment, they must all be considered. If raised at planning stage, designers will need to provide a solution for at building control stage and present that as part of their package there to building control bodies. And more detailed consideration of these usability issues will be required in further policy development stages. We have a number of questions within the consultation document. I believe we've got 9 questions. I won't go through them all today, but they're on the screen there. They're available within the consultation document, which you can download from our website. Things like, do you agree that local regulation guidance is needed here to mitigate overheating? And questions are relating to the proposed approach that we have outlined within that document. Again, the last 4 questions there, and we encourage you to provide or to answer all these questions and provide any feedback or any experience that you have with overheating mitigation within England, Scotland or Wales to date, and any lessons learned. So that leaves us or moves us on to any questions that we may have, John, within the Q&A box.